guys, welcome to another episode on complex numbers. Last video we took quite a lengthy dive into the theory behind sets and how they're built up and how to read set roster notation. And the reason we did that is today we want to build up our understanding of complex numbers. What are they? What do they look like? What are their building blocks so that then we can use them using basic arithmetic. We're essentially going to do the kind of thing that Cardano did with negative numbers. We're going to build up the rules for basic arithmetic working with these new numbers called complex numbers. So firstly, let's go through by way of a few examples working with complex numbers. So the simplest kind of place that we can meet them is with the really elementary quadratic function or quadratic equation, x squared plus 1 equals 0. Okay, and if we try and solve that using our traditional methods, we're going to see there is no solution. Because if I subtract 1 from both sides, I'm going to get x squared is equal to negative 1, and there are no two real numbers that multiply to give me negative 1. Okay, so we need to basically introduce this new unit called the I, or called I, not the I, just I, which is kind of like 1 for complex numbers. It's the basic building block. So we can say that the solution is plus or minus the square root of negative 1, because there's two possible solutions to the quadratic, and we're going to call that square root of negative 1 I. Okay. More traditionally and more concretely, we're probably going to call it, talk about it in terms of I squared is equal to negative 1. So I is the number that when I multiply it by itself, I get negative 1. Okay, a more complex example, basically building on what we just said, instead of saying x squared plus 1 equals 0, we could make it any number, a. So x squared plus a is equal to 0. We're going to run into the same problem with the real numbers. When I subtract a from both sides, I'm going to get x squared is equal to negative a, and I can't do that in the real numbers. But now that we've got this idea of the imaginary unit, we can work with that. Because I can say that the solution to this problem is plus or minus the square root of negative a. I can break that cert apart to get plus or minus the square root of negative 1 times the square root of a. And we've said that the square root of negative 1 is just I, so the solution is actually plus or minus the square root of a times I. And in algebra, we just omit the times symbol, so plus or minus the square root of a I. Okay, what about the general quadratic equation though? If we have ax squared plus bx plus c equals 0, and here we're saying that the discriminant is less than 0, that bit underneath the square root in the quadratic formula is less than 0, what happens? Well, let's have a look. If we just plug it blindly into the quadratic formula, kind of like Cardano did, then we're going to get, well, in this case it is the generic quadratic, so we're going to get the quadratic formula. But I can recognize that bit underneath the square root, because I've said it's less than 0, if I multiply that by negative 1 and flip those pieces around, then that bit underneath the square root is now positive times the negative 1. So we can deal with that bit of the square root now. We can break that apart and pull out that I, and that square root is now positive. Hopefully that was not a convoluted way of saying it, but essentially what we're doing each time is trying to bring out a factor of I, this new imaginary unit, and then we can, the bit that's left underneath the square root is positive now, so we know we can deal with that. That's a normal number. Okay, so we can break this into two pieces. We can break it into the first bit of the fraction, the negative b on 2a, and then we've got this plus or minus the square root of 4ac minus b squared over 2a, and that's multiplied by this unit of I. Okay, so we've broken it in general. When we get a solution like this, it's in two pieces, a piece with an I and a piece without an I. Okay, so all complex numbers can be written in this form, x plus or minus iy, or the solutions to any quadratic in this case can be written as x plus or minus iy. There's two answers, so two complex numbers there. X plus iy or x minus iy, they're the two complex numbers. What we notice is that those x's and y's, as complex as they look like in this example here, they're just real numbers. So complex number is actually in two pieces, and those two pieces have real numbers in them. The only thing that's imaginary in this whole world of complex numbers is that unit I. Everything else is to do with real numbers. So hopefully that's going to mean that things are quite nice to work with. Okay, so we can now define what we mean by a complex number in that set roster notation. They all look like this. C for complex, is just the set made up of numbers in the form a plus bi. And then we define, well, what does a and b mean? A and b are real numbers, and I is just the square root of -1. Okay, so that's what every complex number looks like that now. It's a plus bi, and a and b, they're just real numbers. The only thing that's imaginary is that I, the square root of -1. That's the only bit that we had to make up. Everything else is just normal numbers that we're used to dealing with. Okay, and we call this Cartesian form, and we're going to see why in a lesson or two, why it's called Cartesian form. But hopefully you can guess, given it's got that word Cartesian in it, it has to do with the Cartesian plane graphing these things and what they look like. Okay, so our complex numbers, we've said, or our real numbers, I should say, we can now view them as just a subset of the complex numbers. If b is 0, if that part attached to the I is 0, then a is just a real number. So all our real numbers that we're used to dealing with before, now we can see them, they're just complex numbers with no b. Well, not no b, but b is 0. Okay? And if b is not 0 and a is 0, so the other way around, they're what we call our imaginary numbers. So they're the numbers that only have i's in them. Okay, and we've never seen those numbers before. We've never seen general complex numbers before. They've been hidden away. But it turns out that our real numbers are only a really small part of this bigger system of numbers called the complex numbers. Okay, and a key point there is that, and I keep saying it, a and b are real numbers. The only thing that's imaginary in this whole new world of numbers is I, the square root of -1. Everything else is to do with real numbers. And that's it. So we've defined the complex numbers. In the next video, we'll look at, well, how can we do basic arithmetic with complex numbers?